All right, here we have our three standards, but more specifically, we're going to look at investigating exponential functions. We're going to look at the domain, the range, asymptotes, zeros, intercepts, interval of increase or decrease, rates of change, and end behavior. Okay, and then we're going to graph these functions based off of transformations. So we'll look at what the basic graph looks like and then see what effect the different things we do to it have. And then we're going to understand and use basic exponential functions as models of real-world phenomena. So this will be our essential question that I want you to come back and answer at the end. From 1990 to 2000, the population of Florida increased by 23.5%. The population in 2000 was 15 million, close to 6 million. What was the average annual increase from 1990 to 2000? Okay, and then I want you to write a model, write a function for the population, and then estimate. Okay, so we'll come back. I want you to come back and do this after you go through the lesson. All right, well, we've got some vocabulary here. First is exponential function. What is an exponential function? First, it has the form y is equal to a b to the x. Now, b is our base, and a is any value in front of it that we're multiplying by. But a cannot be 0. It can be anything but 0. Because if we know if we multiply anything by 0, we get 0. And then the base has to be a positive number other than 1. Because if it's 1, you get the same thing over and over again. Now, in this lesson, we're going to look at growth. In the next lesson, we'll look at decay. But right now, we're going to look at growth. They both have the same basic form like this. But in this case, when you have growth, a has to be larger than 0. And b has to be larger than 1. And then whatever your base is, that's the growth factor. And then we're going to come up with the asymptote. Now, the asymptote is a line that our graph will get closer and closer to. It won't cross it, but it'll get real close to it. And so it's a place where our graph does not exist. And then we're going to look at end behavior. What happens at the end of the graphs as we go to positive or negative infinity? Alright, so let's look at a first example here. Now on this one, we're going to graph y is equal to 4x. And we're going to do it from -2 to 2 and see what our graph looks like. So the first thing we're going to do is we're going to find our domains. And we're going to define those as -2, okay, -1, 0, 1, and then 2. Now, we could choose any other values, but we're going to just do the integers from -2 to 2. Okay, then we have y. What are we getting out? So, what we're going to do is take 4, plug in -2. Okay, so we end up with, now we have this negative exponent, which we did. If you have a negative exponent and you put it underneath, remember it becomes positive. So we'll end up with 1/16. Okay, and then we do the same thing for -1. Put 1 over 4. Okay, that becomes 1/4. Okay, now if we put in 0 for x, remember anything to the 0 power is 1, so we end up with 1. Okay, then 4 to the first power is going to be 4. And then 4 squared will give us 16. Okay, so those are our points that we're going to graph. Alright, so we're going to graph on our coordinate plane. Alright, so when we're at -2, go over 2, we're at 1/16. Okay, then when we're at -1, we go up just a little bit, and we're at 1/4. Okay, then at 0, we jump up to 1. Okay, then when we're at 1, we go up to 4. So it would be somewhere up in here. And then finally at 2, we jump all the way up to 16, which is going to be somewhere way up in here. Okay, and so what we're going to do is try to draw a smooth curve. Alright, now it's getting closer to the x-axis, but it's not actually on the x-axis. And then we come up here and we're going to just get really big really fast. And so that's what an exponential function looks like. Now let's talk through this. Now this graph has a horizontal asymptote which is equal to the x-axis. Now the x-axis is when y is equal to 0. That's the equation of this line. When y is equal to 0. Is the equation. So that would be our asymptote. Y equals 0. So that's, it'll never cross that. Now, in behavior, as we get here, as we go to positive infinity, what's happening? Are we increasing or decreasing? We're increasing. So as x goes to positive infinity, okay, y goes to positive infinity as well. So it increases, or we can say it increases. That'd be our end behavior. Okay. Now, it asks for the average rate of change. Now, the only thing that's a little bit involved in this is we're going to have to deal with some fractions. Now, remember, an average rate of change is for a line would be slope. So what we're going to do is take y2 minus y1 over x2 minus x1 and figure out what our average rate of change is for this. So we'll start out with not 1/16. We'll start out with 16 and subtract 1/16. So that was y2, y1, x2 would then be 2 minus -2, so we end up with plus, so we end up with 4 on bottom. Now, we have to subtract a whole number and our fraction, we got to make them the same denominator, so we put the whole number over 1, multiply this by 16 and this by 16. Alright, so we end up with 256 minus 1, okay, over 16, so we end up with 255 16 over 4. Alright, now what we're doing here, I'm going to try to write this out. So we have 255 over 16 divided by 4. Well, we're dividing a fraction by a whole number, so we put the fraction, put the whole number over 1, then we're going to flip and multiply. So we end up with 255 over 16 times 1 over 4, so we end up with 255 over 64 as our average rate of change. Or we could write it as a decimal as 3.98. Either way, that's the average rate change.